Hello, welcome to today's class. Today we have to take this web lecture 6. In the web lecture 6, that we know that we have already discussed the details about the principle of superposition, reflection of waves, reflection of progressive wave, and also we have gone through the derivation of stationary wave. And in this regard, we have also discussed that whenever the stationary wave is produced in a medium, then the medium particles are definitely come within some boundaries. And within that boundary, only the particles of the medium can vibrate. And beyond that, vibrate left or right of that boundary, there is no vibration at all. There is no vibration, no particle is allowed to vibrate. On the other hand, when we call the progressive wave, it is continuously moving. When we say that a progressive wave is propagated from one place to other, that means it is a non-stop movement. It is continuously, it could move. Okay, this is what we have, a progressive wave and a stationary wave. Suppose we speak something without any, it is a open space and there is no person who is there to place any placard or any other obstacle. And if I speak loudly, then it is a continuously movable wave. That is a progressive wave. On the other hand, if we have a string and we just try to just pull it, let us see how it does. Suppose we are having this as the string. Now you can see that I am in fact pulling it, or I am even pulling it in one direction. Then what you can see that at some points we are having this nodes and somewhere we get the antinodes. Both the things are there. At some point we are having nodes. These points are definitely the rigid ends. They are the point of nodes, and the points where the maximum amplitude there. This is antinode. Okay. And you can see that antinodes and nodes are produced with the this is an elastic string, and not string but it is an elastic piece of elastic, and which we generally use in any clothes and other. And suppose I just make one jerk over here. You can see I am not in fact stretching that, but I am just making jerk. That means vibration is there, and there is always some point where we can have that type of thing, that is what we call this nodes and antinodes are produced. Nodes and antinodes are produced definitely, and there we can see that one type of motion, that is your stationary wave. Okay, in any musical instrument like tabla, guitar, or we have bongo, congo everywhere, where there is either the vibration of air column or vibration of stress string, which can produce some type of music. And I won't take anything like piano or what we call this synthesizer, because that is a combination of musical instruments. I won't take that thing, but I would take only single one. Most of the musical instruments, they are definitely showing the concept of stationary wave. Now today we have to explain what are the basic difference between the progressive and stationary wave. Let us see point wise. Number one, that is the vibration or the disturbance travels towards forward with a fixed speed. एक ही स्पीड से जो है कांस्टेंट स्पीड से एक डायरेक्शन में वाइब्रेशन या डिस्टर्बेंस ट्रैवल करता है, ये हो जाएगा प्रोग्रेसिव वेव में. व्हाट हैपेंड टू द केस ऑफ स्टेशनरी वेव? स्टेशनरी वेव में वाइब्रेशन होता है, बट दैट इज कन्फाइंड टू लिमिटेड एरिया. द वाइब्रेशन और डिस्टर्बेंस रिमेन्स कन्फाइंड to the region where it is produced. जहाँ पर प्रोड्यूस करने से वाइब्रेशन होता है, मीडियम पार्टिकल वाइब्रेट करता है, कम से ज़्यादा तक होता है. ज़्यादा मैक्सिमम होगा तो इट इज एंटी नोड, और मिनिमम होगा तो इट इज नोड. ओके, तो ये पॉइंट्स होता है. तो इट इज कन्फाइंड टू अ पर्टिकुलर बॉन्ड विदिन बाउंड्रीज, so that within a particular region where vibration takes place. Number one. Number two, each particle execute SHM. सारे पार्टिकल SHM करते हैं. प्रोग्रेसिव अगर स्टेशनरी वेव की बात करें तो स्टेशनरी वेव में भी सारे पार्टिकल आपका सिंपल आने मोशन करते हैं, लेकिन there is difference. Difference is that there one point is that is at the nodes. जो भी particle होगा that is always remains at rest position, that could never have any kind of SHR except nodes. All the particles of the medium execute SHR. ये लिखा होगा point number 2. Point number 3, no particle of the medium is permanently at rest. ये चीज बहुत खास बात है कि प्रोग्रेसिव वेव कहेंगे तो लगातार प्रोग्रेस करते रहना, लगातार चलते रहना, इट इज कॉल्ड ट्रैवलिंग वेव ऑल्सो. प्रोग्रेसिव वेव को ये खासियत है, तो कोई भी पार्टिकल परमानेंटली रेस्ट में नहीं होगा. आज अभी रेस्ट है तो कुछ देर बाद फिर चलने लगेगा. नो पार्टिकल इज in the medium is permanently at rest. On the other hand, here the particles at the medium are at rest at nodes. तो ये पार्टिकल्स ऑफ द मीडियम कहाँ पर हमेशा परमानेंटली रेस्ट पोजिशन में रहेगा, दैट विल बी एट नोड्स. ओके. फोर्थ पॉइंट, देयर इज ओके इन फैक्ट इट मस्ट बी देयर इज अ फ्लो ऑफ देयर इज a flow of energy across every plane in the direction of propagation of waves. Remember, there is a flow of energy across every plane in the direction of propagation of wave. जो जिस डायरेक्शन में चल रहा है तो वो एनर्जी भी ऐसे लगता है फ्लो कर रहा है. एनर्जी इज ऑल्सो फ्लोइंग, but that is not possible here. Energy flows only in certain limited area. The energy of one region remains confined in that region. एक ही region में energy is confined. It is not a continuously propagating system. Okay, this is a very common thing, and these are the basic things about the difference between the stationary and progressive wave. You can just see the closer look of this. You can get the broader size difference between stationary and progressive wave, and all the 4 points are very essential. There are other points also, but we have not to take them seriously, because they may sometime use, sometime they are not used. Okay, and after that we will take the next thing in the row that we call that is the application of stationary wave, where we actually use, that is the vibration in organ pipes or vibration in air column, that we take next. Next we take vibrations in air column, organ pipes. Open organ pipe and closed organ pipe. So we are having two different types of system. They are actually the musical system type something. If we have a pipe, hollow cylindrical, metallic cylindrical pipe with both the end open, ends open, and the hollow cylindrical pipe, that is also metal. It is a hollow cylindrical metallic pipe that we call as the open organ pipe, and you can see open organ pipe. It is a hollow cylindrical metallic pipe. Okay. Similarly, here also it is hollow cylindrical metallic pipe with one end closed If one end is closed, then other end is definitely open, and that means here we can have this type of situation. This end is closed, this end is open, and here both the ends are open. Okay, and if this type of pipe we use, that we call as the open organ pipe. तो open organ pipe हो जाता है. अगर हम लोग जैसे कोई हम लोग पेन के लिए हम देखते हैं कि suppose we are having any of the pen, and suppose we are having this pen. When we see this cap, okay, I am just whistling this. The one type of sound is found, and I can blow a little stronger. That means there is a variation in the frequency. That different types of thing with the same length of pipe, we can get different frequency, different wavelength of the wave, corresponding wave, and that type of thing is specifically discussed in stretched wire as well as this organ pipes, or we call open and organ and closed organ pipe. Always remember, there is a variation in the frequency. There is a variation in the frequency, and such frequency are very harmonically maintained. They are very harmonically, systematically they are arranged, and therefore sometimes we just call them as harmonics. And that is open organ pipe has all the harmonics, that is odd as well as even, and closed organ pipe always have only selected, that is only the odd harmonics are possible. That is first harmonic के बाद सीधा थर्ड हार्मोनिक आएगा, उसके बाद सीधा फिफ्थ हार्मोनिक आएगा, सेवेंथ हार्मोनिक आएगा, ऐसे. हार्मोनिक क्या है? हार्मोनिक are different frequencies which are produced in such organ pipes. Organ pipes, when we just try to develop some mathematics for any organ pipe, whether closed or open, always remember we can see that the frequency varies even for the same length of the pipe. That means with the variation in the frequency, we can very easily obtain one thing in a one thing common. That is, these are some multiple of each other. There is a minimum value and multiple of that frequency in odd way or in all ways. Odd ways means either first time or three times, five times, six times, seven times like this, or we can say two times, three times, four times. That is all the things. But in both the cases, there is some harmonicity. That is the molecules. That is the vibrations or frequencies are arranged in a very harmonic order, and that is why we just call them as harmonics. That is odd harmonics or even harmonics. In case of closed pipe, it is only odd harmonics are possible. And N1 is to N2 is to N3 frequencies. N1, N2, N3 होगा. So 1 is to 3 is to 5 is to 7 is ऐसे चलेगा. But in the case of open pipe, all harmonics are possible. Odd भी होगा, even भी होगा. That is 1 is to 3 is to 5 is to like this. That way we can do, and we can very easily express the exact what happened. We can explain it with the flute or other thing. We can explain that in next lecture, how exactly the stretched wire can vibrate and how exactly the air vibration of air column can take place. And with that we have completed today's lecture, and in next lecture we will definitely discuss all the mathematical thing of this thing, that is odd and even harmonics of this open organ and closed organ pipe. With that,